classification model using a MATLAB software. We follow generally in data analysis are we gather data or we acquire the data, we pre-process it, then we identify some condition indicator, we train the model and we deploy it and we get the required output. So today I'm going to use a data set of a 3D printer. So this data set comes from the research by Selkirk University Mechanical Engineering Department. The aim of the study was to determine how much adjustment parameters in 3D printer affect the print quality, accuracy, and the strength. So these were the output parameters, and there were a total 9 input parameters. So the setting parameters for any 3D printer are these 9 parameters like layer height, wall thickness, infill density, infill pattern, then nozzle temperature, bed temperature, material, fan speed. These are the setting parameters, and the output parameters which are measured on any component which is manufactured by 3D printing are the roughness, the tension strength, or you can say ultimate strength, and the elongation. So the basically this data set, the aim of the this experimentation or this data set was to estimate the material which can be used based on the input and output parameters by using KNN and DNN algorithms. So we are going to use certain algorithms. We'll basically check which algorithm gives us good accuracy, better accuracy, and that algorithm we can select, and we can classify, or we can say we can predict the required in material for any product to be manufactured with the help of 3D printer by these setting parameters and the output parameters. So as our first step is to get the data and pre-process the data. So I will start MATLAB. I have already downloaded the data set, and I will open that data set in the MATLAB, and I will process the data. I will show you how to process the data. So you have to just go to the Matlab, and you can go Matlab Online, and you have to log in with your login. You have to log in to Matlab Online. Okay, so I will just clear the. Okay, so I just clear the workspace of the Matlab. Now, the very first step is to upload the data which we are having at our you can say computer drive or at a local drive. So for that we are having here we can say at home tab we are having a upload option. So just go to upload option. I have saved that file on the desktop, so I will go to the desktop, and you have to just search for that. I have saved that file as a CSV file. You can save it as Excel file also, no problem. So I'll just open that file. I have saved it with the name data. So the file is uploaded. So now that file is available in the MATLAB drive, but still it is not there in the workspace. So to read that file, I can use the command read table, or I can use this command import data. if you don't want to use a command, you can click on the import data. The MATLAB drive will open, and here you have to see where is your file is. So this file is there, data.csv. I selected this file and I'm opening this file. Okay, so now you can see the file has opened on the MATLAB. So here you can see, as I told, there are total 9 input parameters and 3 output parameters. So here you can check from A to L, all parameters are mentioned. The first parameter is layer height of material for any component to be manufactured with 3D printing. Then the wall thickness. The third parameter is infill density. How much should be the density? Then the infill pattern, whether the pattern should be grid type or honeycomb type. So these are the, you can say, categorical variables. All these are the number variables in numbers, but this is a categorical variable. Okay. Then next is the nozzle temperature, then the bed temperature. The next parameter is print speed, material, fan speed. These were the input parameters. Now the output parameters were the roughness, tension strength, and the elongation. So here is now once you upload the file in the MATLAB and import it into MATLAB workspace, here the first step you can perform, that is pre-processing of the data, can be done over here. So if you think that some of the parameters are not much relevant, or if you want to delete those parameters, you can do that here. So for that, different options are available over here. And even if uh, in the data set, if some vacant cells are there, that can also be filled. So here you are having that option. If you want to replace the unimportant cell with an AN or any particular value, just click on this plus button and you can replace the unimportant cell with NaN or any value. If you want to replace it with 0, you have to select the option as value and you can select 0 and you can just click on OK. Otherwise, if you want to exclude any row, then uh, which contains the empty cell, that can also be done. So if any cell in the data set is empty, you can exclude that complete row, or if you want to exclude the complete column with empty cell, you can do that also. As our data set right now is not having any empty cell or the unrequired parameter, we need not to do that. So again, one more thing is, if you want to select certain parameters from the given data set, here you are having that option. That is, if I select only, if I want to select, say, first 3 columns only, okay, and I want to neglect all other parameters or features, you can say. So you can do that also here. So here you will see that in the selection history, you will see that A2 to C51 are the you can say cell in this particular data set are selected, and those can be imported to the MATLAB workspace. So these kind of data pre-processing can be done over here while importing any data set. So even you can delete the the feature which you don't require from this data set also. Now as we require all the parameters, I'm not going to delete anything. And here you can see we are having 51 instances for all these parameters. So after this, once you have checked that all your data is correct, and there are no empty cells or no any, you can say, anything that is not required in the data set, is once it is verified, you can click on the import selection. Okay, so as I click on the import selection, the MATLAB workspace, you will see that the data is in the MATLAB workspace. But here you will see that the value is one by one table. This is happened because in the selection history, you can check only one cell is selected by me. That's why on the workspace, it is showing only one value. So what I have to do is I have to select all the columns, because while showing it, I was unfortunately, I have selected only one cell. So that much data is only imported in the MATLAB workspace. So I will select all the features, and now I can click on the import selection. Now here you will see that total 12 50 by 12 table. It means that there are 12 attributes, 9 input and 3 output parameters, and 50 are the number of instances. The first row contains the name of those variables. So as we have seen, there are total 51 instances are there. So here it is showing the values as the size of the data set as 50 by 12. So after clicking on the import, the data is imported in the workspace. Now, if you click on the home option, our next step would be uh, here in the MATLAB, you are having a provision that you can select any kind of machine learning algorithm. For that, you will have to just click on the apps option. So you are having all the apps available in the MATLAB. Just check here uh, which type of the learner you want to use, that is whether classification learner or regression learner or any other kind of learner you want to use. So I will just select a classification learner. So once you click on the classification learner, the classification learner window will pop up. Okay, so we have a classification learner. Now here you have to select on the new session, and as we have already imported data in the workspace, you can click on from workspace. If you have not imported your data set in the workspace and it is in the MATLAB drive, you can click on the from file. So if you click on the from file, it will navigate it to the MATLAB drive. Okay, and if you click on the workspace, it will be navigated to the MATLAB workspace. Okay, so this new window has pop up, which has detected the data set which is available in the workspace. So as only one data set is available in the workspace, it is showing that data set variable as 50 by 12 table. The responses includes uh, the material is your response, and the predictors, that is the input parameters, will be the remaining parameters. 11 parameters will be there as a predictor. So here if you want to change your responses, you can change your responses also. Okay, now here my aim is to find out the kind of material to be used, so I have selected material as a response, and all other parameters are selected as a predictor. So here you are having a choice that you can remove some of the parameters if you require. So just untick the parameter which you don't want to use as a predictor. So you can do that also. So I'm selecting all the parameters as a predictor. Now, next here you can observe there is a validation scheme. So we are generally using a cross validation for developing any algorithm, and I have selected 5 folds for the cross validation. This we have seen in machine learning, artificial intelligence and machine learning. That what is the cross validation fold? It increases the accuracy of your model. Now, as we are going to test our data, so there are two options which are available. One is that you can separate the data uh, initially itself before getting a data into a MATLAB as test data and training data into a ratio like 30 to 70, in the ratio of 30% to 70%, or the MATLAB is having provision that you can set aside your test data. So I'm keeping my test data uh, for testing purpose. I'm keeping 30% of the total data for the testing purpose. So remaining 70% data will be used for the training purpose. And generally we are using more data for the training and lesser data for the testing to have a good model of for the prediction. So that you can select over here. So I have selected 30% data for the testing purpose. So after this, you can click on the start session. Okay, so once you click on the start session, if you click on the summary, we have imported one model, and by default, the MATLAB has taken a tree for this, and here you can see the summary. But before that, uh, we are having different types of, you can say, algorithms which we can use, or classifiers which can be used for classification of this data. So we are having a support vector machine where we are having all the types of support vector machine: linear, quadratic, cubic, fine, medium, coarse, Gaussian, and all SVMs also can be selected. So if you click on all SVMs, the model will be trained for all these types of support vector machines. We are also having other types of, you can say, algorithms like neural network classifiers also, and ensemble classifiers also. Okay, so we are also having Navy based classifier and logistic regression classifier also. We are also having a decision tree. We can select any kind of algorithm which we are interested in. So for a while, I will select all kinds of SVM, and we'll check how much accuracy is given by each of these support vector machine for the given data set. Okay, we'll do that later. But before that, one more thing that I want to share with you is there is one tab that is called as a feature selection. So if you click on the feature selection, now suppose as you know that there are total 12 features are there in my data set, out of which one I am using as an output. So remaining 11 features are there where these features are listed over here, as you can see. Now, suppose I want to apply some feature ranking algorithm to this these features like MR, or I want to use ANOVA or other types of feature ranking algorithm, that can also be done. So for that, I will have to just click on the that particular algorithm. Suppose I want to use ANOVA, so I will click on the ANOVA algorithm for the feature selection. So here you can see the features are ranked using this ANOVA method, and the most ranked feature is the nozzle temperature. So nozzle temperature is the feature which is affecting more on the output of the data set. So uh, here, if you want to neglect some of the features which are not required, or which are redundant, or which are not affecting much to the output for the model, you can minimize these number of features from here. So if you click over here, now initially it was 11, now it is 10, and you can go on reducing the number of features required for your data set uh, by applying a feature ranking algorithm. Okay, so that facility is also available. So I'm not going to use a feature ranking, but will keep all the features for our training purpose. So this is one thing that we are having in the MATLAB. Second is here we are having a PCA option. Now PCA is nothing but as you know, it is a principal component analysis. The principal component analysis is used for the to reduce the features, number of features into number of required features. So if you click on enable PCA, that is principal component analysis, you will see that you can select the number of components for the PCA. So which you can reduce to your required value. That means as there are 11 total features, and if you want to reduce it to certain number of features, okay, so that effect of those features should remain in the features which we are selecting. So that is what the PCA is, and that we can do from this particular tab. So if I click on save and apply, only 6 features will be selected for the analysis. Okay, that is what the PCA is. Okay. So as I told you, if I want to use the say support vector machine, then I will have to just click on the support vector required support vector machine algorithm. So initially what I will do is I will use all SVMs. So you have to just click on all SVMs. Now here you will see that in the left pane, you will see the multiple SVMs are there or all SVMs are there. The next step of our once the model is selected, okay, we have pre-processed the data. We have identified the condition indicator that I have to select the proper material for given input parameters. The next step is to train or the prediction model. Select the prediction model and train that particular model. So here I have selected the all the SVM model. So my next step will be training of this model. So for this, you have to click on the train all. You can train all the models which are available over here, or you can train the selected models. So I'm training the selected model, that is all SVMs. So if I click on the train selected, the MATLAB will train all the support vector machine algorithms, which you can see on the left side. So now it is training. Okay. So after training that model, you can see that the model 2.1, which we have used SVM method, the model is trained, and the training results you can also observe over here. So accuracy of the validation of this training is around 97.1%. The total cost of validation is 1, and the prediction speed is 400 objects per second, whereas training taken by this model is 14 seconds only, 14.43 seconds. So all these parameters are the parameters which we required while developing any model. These are the criteria for the model selection, that we have to check the accuracy of the model, we have to check the prediction speed of the model, training time taken by the model. So all this result is displayed over here. Then from the list of all these models, linear SVM, quadratic SVM, cubic SVM, we have to see that which model is giving more accuracy. So for that, you are having one option over here. Based on accuracy of validation, you can rank the models over here. So here the ranking is changed, you can see. So quadratic SVM is having 100% validation, whereas cubic SVM is also having 100% validation, and remaining all are having less than 100%. So we can select either of this quadratic or cubic SVM model. So I have to just click on the quadratic SVM model. Okay. So now once you have selected this quadratic SVM model. Uh, if you want to, I'll just maximize this window. Okay. Okay. Once you have trained the model, uh, if you want to plot certain graphs for this, um, so I will train the selected model. So it's showing that it is training the model. Okay. So here you can see we are getting accuracy of 97.1%, and we can also see a confusion matrix. If you want to plot a scatter plot, we can also do that. We are having a provision to uh, show this confusion matrix in this way, that is in the form of true positive and false negative rates. We can also show this confusion matrix with this positive predictive value and false discovery rate just by clicking over here. So you can see a true class and predicted class, and you can save this image also. Here you are having a facility that if you click over here, if I just click on this, you can save this file as JPG image also. Okay. So along with these plots, there are certain other plots are also there. That is ROC curve. We know that we use it for model validation purpose, or model, you can say selection as a model selection parameter also. So that can also be plotted with the help of this option. So here you can see the ROC curve. Okay. And we can change the class also. For ABS material, it is now I can make it uh, change it to positive class as PLA also. So this is what the ROC curve is that you can plot with this. Now this is what the model is trained, but I want to test this model also. So for that, I will have to click on test all. Here I will select on the test selected. So if I click on that, the model will get tested. So this model has taken 30% of the data for the testing, as we have given 30% data for the testing initially itself. So here in the summary of the model, you will see that initially it was showing the training result of 97.1%. Now it is showing the test result of 100%. So your accuracy of testing is around 100%. So if you want to plot that graph also, that is confusion matrix of the test of the data set, testing data set. So here you will see that is also done over here. So the number of you can say the instances are 7 plus 8, that is 15, and we know that total number of instances were 50. So 30% of the 50 is 15, and if you check this summation, it will be 15 only. So 30% of the data is taken for the testing. Now once your data is tested, okay, and you have seen that the accuracy is more than 80%, or generally it is taken more than 70%. So you can select that particular model, and once the model is selected, uh, you can have various plots of the model. You can plot a parallel coordinate plot also, where it shows the relationship between all the parameters which we have taken into considerations. So that is layer height and density pattern. So the visualization of the data set can be done with the help of these given plots. Now, once your model is trained, now our next step is that once our model is trained, we deploy the model and we use the model for analysis purpose. So here you are having that option, export model. So just click on the export model. You can name the model which you are exporting to the Matlab workspace now. So I'm keeping it as a trained model. You can change the name as per your requirement and just click on the OK option. Now, if you minimize this, you will see that the train model is there in the Matlab workspace. Now, once the train model is in the Matlab workspace, I have divided the data set uh, or I have taken some trial data set to predict the values. So I will just open that and I will show what I am going to predict. So here I am having certain instances of the variables. There are total 24 instances are there for which I want to find out the type of material based on these remaining inputs. Okay, so I want to classify this data for the given two different kinds of materials. So for that, you have to keep your data set which you want to validate or on which you want to take a trial in the same format as you have given in the input to the MATLAB. Okay, so I'm keeping it in the same form. Just you have to keep the that particular column blank which you want to predict. So I want to predict the material for all these with these variables. So I kept this column as a blank. So I'm closing this. Now the name of this file is trial dataset. So I will just go to MATLAB and to the command window. Before that, I will call that file. I will upload that file, data trial, into MATLAB drive. The file is uploaded. Now that file can import to the MATLAB workspace. So there is option import data, and the name of the file is data trial. Okay. So if you open this file, sorry, I have selected a wrong file. So I will select the file again, upload. Okay, trial dataset. Now import that into the MATLAB workspace. Trial dataset. Open. Okay. Now here you can see all other parameters are there, but the material, this column is blank. So I'm predicting with these features, I want to predict the kind of material that can be used with these variables. Okay. So I'll just click on import selection. Now that is in the MATLAB workspace. Now I want to predict the values of or the kind of material. So I will use this command whose. So it shows you the train model, size of the train model one by one, and the trial data set size is 24 by 12. Now after this, I will name this particular trial data set. So let us say I will call it as A. So A is equal to read table. The file name is trial dataset. Okay, so this trial data set is saved as with the name A, and you will see that in the material it is showing NaN. So in the while importing, we have selected that if empty cell is there, you have to fill it with NaN. So we don't know what kind of material should be used for this data set, particular data set. So for that, if I want to predict that, I will use this. There is one particular command which we can use for this. So okay. So if you click on that, you will get the required output. So here you will see on the MATLAB workspace, Y fit is the your solution, or you can say the prediction for the material. Okay, here you will see there are total 24 instances. So all material values you will get, and these material values you can copy from here. Okay, there were two materials, PLA and ABS, which we have predicted. So you can copy it from here, and whatever your trial data set, I can put it over here. Okay, so so total 20, actually 24 instances are there. Okay, I have not selected all the material values. So there are total 24 categorical values you are getting. So this is how we can predict the kind of material that is required by selecting a proper algorithm or proper model for the given data set. So this is all from my side. So if you have any questions, you can ask. Even you can put your questions in the chat box.